Welcome to all. Part 1, usual I am telling. Part 1, lecture 14 I think. Okay. Leave it. Now see what you are covering now. So far we considered law of parallelogram of forces. Then we considered resolution of a force. We considered both resolution into mutually perpendicular planes. It can be horizontal vertical or two mutually perpendicular inclined planes. Before that also we considered resolution in along any two given directions or given directions need not be orthogonal. That is only theoretical. Go through all the classes. Now we are going for finding the resultant completely for a given coplanar force system. 1 minute now. Be careful. Suddenly coplanar means people will think, oh, he's not doing concurrent. They will tell sometime when I write in the class, coplanar force system. Students has told me earlier, sir, in examination they ask concurrent. Wait for some time. Wait for some time. Do you think I am not knowing that much? What order I have to cover? Yes, sir, you know it. Then, sir, curiosity. Don't question my integrity or the way I am going to teach. Don't question that one. You tell me later when I explain. Okay, start. Note, I wrote just resultant. See here, not resultant force. Reason, this nobody is going to do. All will tell resultant force. No, it is not correct. I wrote just resultant, not resultant force. Because the resultant need not be a force. It is possible that for a given force system, resultant need not be in the form of a force. Some rare cases, it can be in the form of a couple. See, I written here. Most of the cases, it can be a couple. Class, this I told long back while defining. And more of this one will be explained to you when the time comes, not right now. So remember, resultant means never blindly tell it is a force. It can be either be a force or rarely it can be a couple. Somebody will ask, sir, what about force and couple? No. Sir, in the college they did wrong. Finding resultant, finding force and couple, it is not resultant, it is replacement. They should know the concept. A resultant cannot be force and a couple. It is nonsense. It is either a force or a couple. It can't be both. But sometimes question will be given. Replace the given force system by a resultant force and couple. They are asking resultant force and couple. They are not knowing subject properly. It is replacing by equivalent force and couple. I will tell later. Okay, leave it now. Now, most of the cases it will be resultant force. Yes, that I agree. Usually resultant is force only. But rarely the resultant can be in the form of a couple. All these will be thoroughly explained at the correct time. Correct time is when the time comes. Right now if I tell, it will not be clear. When the time comes, when I explain, it will be crystal clear for you. Therefore, class, right now, nothing you can do. Believe me, I think by this time, you got little belief in me that the subject from engineering mechanics change over strength of materials, let it change over to structural analysis or later RCC, steel, pretest concrete, etc. Then I will ask once again, now do you believe me or not? I want the reply at that time. Okay, now, note, we are finding resultant completely. See, I told completely. Completely means what? See, if the result, I told resultant can be either in the form of a force or in the form of a couple. Okay. Completely means if the resultant is in the form of a force, that is, if it is a resultant force, I told first class, then we have to find 1, magnitude of the resultant. 2, you have to find direction for the resultant. Lastly, and also 3, locate line of action of the resultant. These 3 you have to find. Okay, one by one I will explain. Class, what if resultant is a couple? If resultant is a couple, remember, then you have to find magnitude and direction. That's all. No line of action, because why? It is not a force. Okay. This all class will come later when the time comes. Okay, right. This is first part. Now I will write new. Now I will tell answer for those who told, sir, in the college first they started concurrent. I will tell them, wait. First, make a note. We already know how to find resultant force. See, this time I wrote force using law of parallelogram of forces. But remember, but it is only for two, and that too concurrent force system. That is a particular case. Only two, that too concurrent. Okay, now we are considering general case. That is, see, any number of forces, no limit. Any number of forces, no limit. Okay, over. Now, before proceeding further, make a note. I told heading coplanar. Now see, this is coplanar. See here, this also coplanar. This also coplanar. People usually think coplanar means this way. They will tell, sir, this is not coplanar, sir, parallel. Who told? This is coplanar, this also coplanar, this also coplanar. Line of action of all the forces lie in one plane. But here, special, coplanar with concurrent. So you can call this as concurrent coplanar force system. The student who asked earlier, sir, in the college they ask, he will tell, sir, got it, sir, yes. Then why are you hurrying? Sir, I thought you are doing this question. No. First, if I write only concurrent, doubt comes. People will tell it is not coplanar. See, it is coplanar with concurrent. This is coplanar but parallel. See, of course, if all are same, it is called like parallel. That is all not required. Parallel means line of action parallel to each other. Direction not required. And what is this one? This is general. General. No concurrent, no parallel, random. So remember, this is a random. You can write here. Random or general case. Coplanar force system in general. All the three, any number of forces, any number of forces, any number of forces. Now, when I start solving, what I will do is, systematically, I will write Roman numbers. I won't write part 1, part 2 because part 1 all I am giving for main heading. So I write Roman 1. I will tell later, next class I will tell. Roman 1 means resultant for concurrent coplanar force system, any number of forces. Roman 2 means resultant for coplanar force system in general, any number of forces. I will write at that time. Roman 3 is resultant for parallel coplanar force system, any number of forces. Okay, now I will start one by one. One by one I will start now. Now we are starting Roman 1. I told I will round off Roman 1. Finding resultant force. See, I wrote force because I am discussing concurrent force system. There, resultant cannot be a couple. It cannot be a couple. Why, I will tell you later. Finding resultant force completely, very important, completely for a given concurrent coplanar force system. And one thing forgotten here, force system, here, any number of forces. I forgot to write here, big letters. You write big letters, any number of forces. Actually, you should write big letters. Here space is not there. Any number of forces. Or in future, We won't waste time every time telling concurrent coplanar. We'll simply consider concurrent because our study is only coplanar. Okay. Note, completely means we have to find magnitude, direction, and also locate line of action of resultant force. Okay, now, but note, in case of concurrent force system, all forces are passing through a common point. One common point is there. Therefore, resultant force will also pass through that point. Oh, therefore, we need not locate line of action of resultant force. See, class, I will tell you. Or for a concurrent, see, usually, generally, we have to locate magnitude, we have to find magnitude, direction, and then locate line of action. Concurrent means last one, close it. No, not there. Oh, therefore, we have said for a right here. That is for a concurrent force system. You write here. For a concurrent force system, we have to find only magnitude and direction for resultant force. Okay, now, somebody will ask doubt. Sir, if all the forces are passing to one point, resultant will also pass to same point, correct? But then how you can tell line of action is not required? I can explain that one. See, I can explain that concept why, but better, see, right here, let me explain it in the first example or first problem example or question number 1. Then it will be crystal clear. So I will tell at that time. I told earlier, long back, the procedure I told, line of action not required. Therefore, doubt will come. I will explain at that time. I will tell clear. Students will tell, sir, fully clear. Now go back and write there. Or you write here. Here what? If you are preparing your own notes, if you are taking my notes, this all will be there. If you are preparing your own notes, you write there. What? For this one, a note or explanation we will write later when he covers the first question. Okay, over. Now I come to procedure. I told you resultant for a concurrent force system. Over. Last step now. Almost over. Now, procedure. See, simple procedure. Consider reference axis, say x, x, y, y, if it is not given in the question, preferably this way. Okay, this all you know it already. Next, consider each force and find component of that force along x, x and y, y. That is, perform resolution along x, x, y, y. Already over very thoroughly what you are doing all these days with plenty of example. Therefore, if not clear, better not continue my class. After so much of explanation, if you still tell, sir, how to resolve means, I will tell you are not fit to be my student. Okay. Next, find sigma fx and sigma fy. Sigma fx is algebraic sum of components of all forces along x-x axis. Sigma fy, same thing along y-y axis. Now, this all I will explain systematically, very slowly in the first example. So, now briefly, once that first example is over, then come back here and understand. It will be very clear then. Okay, now, very important, while finding sigma fx and sigma fy, use sign convention. Get the answer with sign. Then consider sigma fx and sigma fy in actual directions without sign. See, while calculating sigma fx, sigma fy, use sign convention. Get the answer with sign. Once you get the answer with sign, then write that answer sigma fx, sigma fy without sign but in correct direction. You can make a note here. Note, this will be thoroughly explained in the class coming up. If I tell now, it will not be clear. Because my first question, I always see that sigma fx, sigma fy both are negative. See, usually confusion comes when negative comes. So first question, I see that both are negative. Okay. Then next consider resultant, that is resultant force. Let R be resultant of, let R be magnitude of resultant force, and alpha x, I told angle you consider with x, y you can consider, don't consider. Alpha x with the angle made by resultant force with xx. Note, alpha x with the nearest xx less than 90. This also already explained, but anyway will be again explained later. Okay, now last step now, I will close it now. Now, next, I already told, see the procedure. Find sigma fx and sigma fy, first with sign, then write the answer without sign, but in correct direction. Then mark the point through which all forces are passing. Say O, some point required. Say O, it can be any name. In the question they can give A, B, C, D also, O. Okay, then through that point, mark sigma fx and sigma fy. See here, this way. Then, but remember, mark sigma fx, sigma fy without sign, but in actual direction. Class, already told, will be thoroughly explained when I take up the first example. Through the same point, mark R and alpha x. R is the magnitude of the resultant force. Alpha x is the angle made by R with the xx axis. I told repeatedly, alpha x with nearest xx, see there? Nearest xx, and that is less than 90 degrees, already explained. Now, class, some places, some people, or some books also, they use sign here. When they find resultant here, they use sign here. They are asking for trouble. It will lead to confusion. Sometimes they will make a terrible mistake in some places. So I will explain that one. See what mistake people will do if they continue. Once they get sigma fx, sigma fy with the sign, if they continue it with the sign, what mistake will happen, I will separately explain. Actually not in this class. I told one new course coming up, not course, series of class like brain teaser etc. is coming up. One more coming up now. That is, do not make this mistake. I told you, I know so many mistakes people commit. One among them this one. And I told you also, see, if you remember, for resolving, if you take this angle, what happens? Serious trouble will happen. I told, mark this angle. You should go through that class very systematically. I will explain. It will be that complete series of classes, maybe more than 100, not 100. It may cross even 200 also. Common mistakes committed. I want to teach everybody the mistakes they are teach means teach the correct way or how to correct the mistake they are making, and I will tell them in future, don't make the mistake. Let the structural engineering prosper, shine. Do not make mistakes there and spoil the subject. I again told not to insult or degrade them, to give them at least to bring them back to the correct path. So many mistakes are there. Okay, leave it now. This all I will tell. Now, there are 4 cases. Remember, 4 cases for which one? See, I told you. Mark sigma x and sigma fy here. For this, I write here. There are 4 cases. Case 1, sigma fx like this, sigma fy like this. Case 2, see, sigma fx this way, sigma fy this way. Case 3, sigma fx left, sigma fy down. Case 4, sigma fx right, sigma fy down. In all the cases, see, resultant alpha x, resultant alpha x, resultant alpha x, resultant alpha x. For all the cases, resultant equal to root of sigma fx square plus sigma fy square. And alpha x is tan inverse of other component, your angle is measured with x. If you measure the angle with x, tan alpha equal to other first, f sigma fy by sigma fx, or remember opposite by adjacent side. See, how you got this one? Very simple. See here, if this is sigma fx, see this is sigma fy, this also is sigma fy only. See, Pythagoras theorem. R square equal to sum of these two square, you get this. Already I explained earlier. And alpha, tan alpha equal, see, tan alpha x equal to, here it is angle alpha you are measuring with x. Therefore, tan alpha equal to opposite by adjacent. Make a note here. By chance, if you measure this alpha x, this is, suppose by chance, make a note if you want. See, by chance, write once again. If you mark this angle, don't write now as alpha y, then tan alpha y equal to sigma fx by sigma fy. But we will not do it. Oh, no, one point. I forgot. These are the sigma fx and sigma fy are components of the resultant along x and y. There is a principle is there. If sigma fx and sigma fy are the component of the resultant along x and y, then for resultant R, component along x, x, y, y are nothing but sigma fx and sigma fy only. So, for the resultant, these two are the components. Now, 1 minute. See, now I should have told it earlier. Actually, it's logically proved. There is no mathematical proof required. But still, I always go for proof. See, why I have got this much grip? Because I never consider anything with assumption. It should go inside the blood. Once it goes inside the blood, as long as my blood is flowing, it will be there. There is no question of forgetting. Even whatever is my age later, as long as my brain is working, I can remember everything, all subject. Okay, now, one forgotten, I will tell now. There is a principle. I am not dictating now here, dictating here. See, you write. In the notes I will write. There is a principle of resolution. The principle states that, I will dictate here. When I start the proof, I will explain once again. Proof, the dictation, I will dictate. The algebraic sum of components, resolved components of all the forces along any axis is equal to resolved component of the resultant along the same axis. Algebraic sum of resolved component of all the forces along any axis equal to resolved component of resultant about the same axis. Okay, now I will do one thing now. Now, I will close the class by proving that one. I will add it now. If I have forgotten today, tomorrow I would have to give, next class I have to give. Suddenly remembered. Okay, now last part, I will go for that one and then close the class. Okay, I am going to prove it now. Make a note. For proof, we consider two concurrent forces passing through a point O, for which resultant is R. Okay, already not required, right? This is told so many times earlier. That is, see, P1, P2. It will slant. Okay, no problem. It is same angle. Now, again doubt will come. He is proving considering concurrent force system. That too only two forces. But he is applying for general coplanar force system or even concurrent force system with any number of forces. Doubt comes, why? Remember, for this I am giving clarification bit later. If you remember, See my uploading there. In between engineering mechanics classes, I uploaded a class, brain teaser, then I told hidden concept or some other name I have given there, brain teaser, hidden concept or puzzle, something like that in structural engineering. The first question 1 is this only. I told at that time, we consider that is, I told for Varigno's theorem, same theory here also. For proving Varigno's theorem, we consider 2 concurrent forces. But we applied for any number of forces, not only concurrent, coplanar and parallel. What is the reason? I told earlier, go through that class. It is like proving something for a square, then applying it for rectangle. It is not correct. If you prove something for rectangle, you can apply for square. Or I told one more thing, if you remember. Rule passed in a state. I try to apply for the entire nation. No, not possible. But here possible. The logic of that one, I will tell later. Same here also. For proof, we are considering 2 concurrent forces. What logic given there? Same logic here also. Okay, leave it now. Consider 2 forces P1 and P2 passing through a point O as shown. Let R be the resultant. Consider law of parallelogram force. See, the P1 need not be horizontal. I will take inclined only. Represent P, see, 1 minute now. Represent P1 by side OA, correct? OA, okay. Represent P2 by side OB. Complete parallelogram OACB. Then OC will represent the resultant R. Correctly see what I wrote here. Because I am rubbing this one. I want full board now. Correctly see what I wrote here. Okay, now I'll continue. I'll rub this one. Okay, I can see here. Now only, I am not repairing anything. Right now I will prove it. See. You should write all these things. See. Point O, I'll make the bigger. Okay. Point O here. See. This is force P1 by OA. Other force is here. Force P2 by OB. Then I told complete the parallelogram. 1 minute now. I should see the board because the setting of the board here today is slightly downwards. Should not go beyond the camera. Okay. Complete OA, CB. Then this is the resultant. This you know it already. I won't write the law once again. See, angle, theta, alpha, nothing required today. Just a minute. Check the board, camera. It's okay, no problem. Very, very clearly visible. Nothing to worry. Now, see what to do is, as I told it earlier, this is for resolved component. So, just imagine an axis xx, anything. It can be anywhere, it can be this way also, but usually, see, you take xx axis here. Consider reference axis xx. See right here. This is reference axis xx for resolution. We will prove with respect to xx. If you prove with respect to xx, it is proved with respect to yy also. Only one sufficient. See what to do. See correctly what I am telling. See, from O, you resolve along xx. See. Project it here. Just project. I will call the point as O dash. This I will call A dash. And then from B also drop project it here. Correctly project. I will call this as B dash. For some reason, even project the point C also. C dash. Now remember, see correctly. For force P1, See, force is here. This is the x component, or see here, P1 starts from O dash, ends at A dash. So this is your Px. Component P1x, this is your P1x. That is, let P1x, capital X, okay. Let P1x be resolved component, okay. Resolved component of P1 along x-axis, along x-axis. Okay, see, that is, and it is equal to what? P1x will be equal to O1A1. O1 A dash, okay, O1 A dash. It's a dash actually, okay, no problem. A dash, okay. Okay, next. Let P2x be resolved component of, this is P1, this is P2 along x-axis. P2x equal to, see here, your force P2 is here. Starts from O to B, project here. Here, see, here. So this is your P2x. Okay, next, P2x equal to O dash B dash. O dash B dash. Next, let Rx be resolved component of resultant R of, actually not required, of resultant R along x-axis. Along x-axis. So surely your Rx will be equal to, your Rx, x is black color, Rx equal to, see, R starts from O, ends at C, see here, so project here. So it is O dash to C dash, O dash to C dash. Now you have to prove that P1x plus P2x equal to Rx. That is algebraic sum of resolved component of individual forces, any number of forces, equal to resolved component of the resultant along the same axis. Okay, how to prove now? See, now, therefore, P1x plus P2x equal to, see, we already got P1x equal to O dash, is O dash actually, O dash A dash plus O dash B dash. O dash A dash plus O dash B dash. But O dash B dash equal to A dash C dash. Why? So simple. See, whatever P2 is there, see, if this is P2, remember, this also is P2 only. Therefore, see, this is the component of P2. See here, for this P2, if I replace here, this is the component. So this will be equal to this one. Crystal clear it will be. Therefore, your P1x plus P2x equal to O dash A dash, see, already over, plus instead of O dash B dash, you write A dash C dash plus A dash C dash. But O dash A dash plus A dash C dash equal to, see here, O dash A dash plus A dash C dash equal to O dash C dash equal to O dash C dash. O dash C dash is what? Is Rx. Is Rx. See here, Rx. That is same Rx right here. That is resolved component of resultant R along x-axis. Therefore, little earlier statement, you write there, little earlier statement That is algebraic sum of the resolved component of all the forces for a given force system along any axis is equal to resolved component of the resultant along the same axis. Write once again if you want. Therefore, if you want, write once again. Therefore, see here. Finally, what you got? Or you can write, therefore, you finally get P1x plus P2x equal to Rx. Over. Proved. Algebraic sum of the resolved component of the given force, all the forces of the given force system along any axis is equal to resolved component of the resultant along the same axis. So theorem is proved. Over. Actually, this is very unheard theorem. Actually, it is a logical proof is there. This much not required. It is common sense. When you replace a given force system by resultant, see, algebraic sum of the given component of given force system along in any direction or along any axis should be equal to component of resultant along the same axis. It is logically you can prove it, but this is a mathematical proof. Therefore, this I told this one, if you remember, little earlier when I found resultant for concurrent force system, that is what I told, Rx resultant are equal to root of sigma fx square, sigma fy square. At that time I told, so this is a proof. Actually, this proof I should have done it earlier, but I forgot it. Forgot means not I forgot the theorem, because this is well-known fact. Okay, now over. We will meet in next class number, I think today is 15, huh? Yes, most probably 15, I forgot now. I wrote earlier, but I forgot. Next class we will meet, and remember, next class is the most critical class. We are starting plenty of numericals. How to find resultant for given force system in systematic order. First, concurrent force system with any number of forces. See, law of parallelogram of forces you can apply only for two forces. Now, you see there, any number of forces. What we will do is, any number of forces. See, this way. Or coplanar force system, any number of forces. Or parallel force system. Some may be up, no, there's no problem. Or even this way. So this all will cover in correct order systematically. First we will consider concurrent force system, but before going to coplanar, you require the concept of moment, because there line of action is required. I already told earlier, which you can obtain or which you can locate only if you apply Varigno's theorem. Okay. Wait for next class. Systematically we will start the problem. Very systematically problem will be solved. Okay, thank you. We will meet in the next class.